Hey, did you ever wonder how hard it would be to create your very own animated videos for illustrating mathematical concepts, just like, for example, Grant Free Blue Von Braun Sanderson in his videos? Do you maybe even have a little bit of knowledge in Python? In this case, the Python animation library Manim might be what you're looking for. Let me give you a very quick example of what Manim can do in just a very few lines of code. You might be aware of the fact that the unit circle in the complex plane can be parameterized using the complex exponential function. Lifting the corresponding curve into 3 dimensions so that it becomes a spiral then allows us to see the exponential function's real and imaginary part, given by cosine and sine respectively, simply by changing our perspective. In my opinion, animations like this make all sorts of mathematical objects, or results, much more approachable and easier to grasp. This is why I want to help you learn how to use the library to create insightful animations like that yourself. You might wonder, who is that guy even? Why should I listen to him? You're right, I have not introduced myself yet, and I should tell you about my background. My name's Benjamin. When it comes to mathematics, I really like counting, do combinatorics, and I did actually a PhD in that. But more importantly, I'm currently one of Manim's maintainers. In other words, I've been working with Manim for a reasonably long time. As a hobby, I help out when it comes to fixing bugs, developing new features, reviewing the contributions of other volunteers, and making sure that we push out new releases from time to time. Now, with that out of the way, let's get to business. The first part is about, important things you should know before you start. So probably the most important thing to know when you're getting started with Manim is that there is not one single version, but there are multiple incompatible versions of Manim floating around. And it's quite easy to get lost in some outdated tutorial or something that uses the old version instead of the one they should be using, namely the community maintained version. This is what I mean when I say Manim, and this is also how the package on the Python packaging index is called. It's just Manim. No Manim CE, no Manim GL. These are different versions. So when I speak of Manim, I in most cases I refer to the community maintained version. The other version that usually pops up quite frequently is the original version, 3b1b Manim or Manim GL. When you see code, you usually see a reference to Manim lib. This is not the community maintained version. That's the version that Grant has written originally and which he maintains himself, more or less. For all practical purposes, however, it's recommended to start working with the community maintained version, simply because it's much better documented. The original version, there is some sort of documentation. It's pretty bare bones, but the community maintained version has proper documentation. And needless to say, this video also is about the community maintained version. Which brings us basically already to the next question, namely, how do you actually install Manim? I won't go into detail, and I won't. This is not a step-by-step installation guide for Manim. There are 2 ingredients basically that you need. On the one hand, you need a reasonably recent version of Python. Everything from 3.7 and up is sufficient. And on the other hand, you need FFmpeg, which is a command line tool for working with videos. Manim uses that to stitch together several renderings to one big video. Optional but very useful is a LaTeX distribution. For Windows, this is usually MikTeX that's recommended, and for other platforms, TechLife is usually the way to go. There's also MacTeX on macOS, but details for all of that can be found in the documentation, and it's most important that if you say, I don't really want to read, I'd rather watch a video to guide me through the process, I'd recommend against that, because most installation videos are simply outdated at this point. The community maintained version has moved pretty fast at some stages, and most videos were created before that. And nowadays, the process is not that complicated. So my recommendation is go to the documentation of Manim. We can go right there. We couldn't go there right now and have a look. You see there is this installation section right here. Head over there, select the correct operating system, and then just follow the steps. And in most cases, this should work as expected. So that's regarding installation. I won't really, as I've said, I won't really go into detail here much more. But something else that's very important is you should know where to find further resources. And pretty much all resources that the community surrounding Manim has are listed in some way on our website, which is just manim.community. You can visit. Looks like this currently, which is pretty nice. We even have some examples that you can view right on the page, but we'll get into code in a little bit. If you're specifically looking for places to get help with problems, for example, installation issues, which tend to appear from time to time, there is the number one resource in that regard I would consider is our Discord server, which you can find at manim.community/discord. Reddit is also sometimes quite useful for asking for help. There's a Manim subreddit which you can ask your questions in. All of our development happens on GitHub, and there is the GitHub discussions thing where you can also post questions and we'll get answers usually by developers or other people that are interested, which is also helpful from time to time. The most important thing when looking for help definitely is make sure to post your entire code that you're trying to run and then all of the output that it produces. If there's an installation issue, exactly describe which steps you've been taking. Post the input, post the output. We need to see these things in order to help efficiently. Don't worry about if it's a long post. Then we usually look at the details that are interesting for us to figure out the problem and then help you as efficiently as we can. Which brings us slowly a bit closer to the coding part of this video. Specifically for this video, you don't need to have Manim installed locally on your PC, because what I'll provide in the description of the video is a link to an interactive worksheet where you can run the examples that we'll go through in the rest of this video online in your browser. You don't need anything else set up. You can just use your browser and do everything from there. A link for that is in the description. Okay, it's time to actually look at code now. I want to start with the first rather simple example. Before I open up a code editor and just go ahead, I do want to sort of do this still in this presentation style. We'll cover line by line, and in the end, I'll show you two ways how to turn this code into, well, the actual video in the end. So let's get into it. The first line, it's the line where we import the library. Then the next relevant line is the line where we define a class. Now, Manim's design basically works like you write your animations in classes. Every class will have a particular method, the so-called construct method, and within this construct method, your animations will play, or you're going to write your animations in this particular construct method. You don't need to know too much about object-oriented programming in order to understand all of this. Conceptually, just think of the class as, well, basically the object representing your canvas, and the construct method is more or less a step-by-step guide how your animation should be constructed. Looking at this again, and in case you understand something of object-oriented programming, then you will see that we define a class of the name first example here, and this class inherits from scene, and scene is a class that Manim provides. So scenes are these special sort of canvas like structures where our animations will be created on. And well, I've already mentioned this special construct method, which has one argument, self, and you can think of this self, if you're not familiar with object-oriented programming, as the scene. So if we then use some command self.something, then it usually means the scene should now do something, which makes sense and is actually quite readable in the way that it's written here. Okay, let's now see what the next two lines do, 5 and 6. I define two variables. One is called blue circle and the other one is a green square. And well, it would be pretty disappointing if those were not a blue circle and a green square. Indeed, we create so-called manim objects, or mobjects for short. One is a circle for which I pass the color blue and the fill opacity 0. And the property, that's the fill opacity of 0.5. You can see that these capital letter constants, blue, green, you'll also see right in a moment, these are also provided by manim, just as the classes circle and square are. Those are mobjects. Those are the things that you put on your screen. At this point, we have created two variables containing, well, a blue circle and a green square. What has not happened yet is those are not added yet to our canvas. You're basically holding them in your hand right now, and they are available. For adding them to the canvas, but this has not happened yet. This is very important. Just instantiating these mobjects does not automatically add them to the scene, and this is actually quite useful because you want to do that. You want to decide when exactly the objects should appear on the screen. This line is about positioning. It tells the green square that it should be placed next to the blue circle. Something you have to know in this context is whenever you create an object, its center will be placed in the center of the scene. We'll see how that looks in a moment. In your imagination, you can see that the green square should now be right off the blue circle. Blue circle in the middle and the green square right of it. And now in the very last line of our construct method, we finally add the mobjects to the screen. So this is the step that actually takes the thing you've been holding in your hand and puts them onto the canvas. Asking manim to render this scene now will produce an image that looks exactly like this. How exactly can we ask manim to render the scene for us? Well, there are two main ways that you should know about. You could either do it the normal way. I'll show you an example right up there, where we take this code that we've just discussed, we write it in a Python file, and then run the manim command line utility from the terminal. In this case, it would be manim -qm-p, then the file name, and then the name of the scene that you want to run, and it will render the file in medium quality. That's what the QM stands for, and then preview the output, which is why we have this little -p. The other way how to generate output is if you are using manim from a Jupyter environment, like the interactive notebook that accompanies this video, also link in the description. There we, again, example above, we import manim in one cell, put our code for the scene in a different cell, and then in the same cell where we have the code for the scene, we add on top an instance of this manim IPython magic command, which in this case reads as $% manim -qm, and then the name of the scene we want to render. QM in this case, again, medium quality. We don't need the -p flag because the output is automatically displayed. So we don't need to take care of that separately. To make sure we're not moving too fast, here's a short recap of the things we've already seen and the concepts we have encountered. First, we have met the scene. The scene is basically the animation canvas, where all of the things that you want to display are placed upon and then arranged somehow and then eventually also animated. We have encountered mobjects, Manim objects. In this case, we have seen circles, we have seen circle and square. There are many others. There are like axes for plotting functions. You can have a number plane with grid lines. You can have a table. You can have a graph and many other things. We have also seen already that when we create objects, we can give them some sort of properties. In particular, we've seen color and fill opacity, but you can imagine there are lots more, especially if you are looking at more specialized objects. We have also seen some global constants. In this case, we have seen colors, blue and green, and some directions. In the last example, there was only right, but you can imagine there is up and down as well, left as well, actually also in and out, but those are not that important right now. You might wonder, well, now I know that there are these constants and objects, and I know these now, but where are all the others, and how do I know what exists? That's very important. We have in our documentation, there is one section called the reference manual, and the reference manual contains all the content, all the functions, all the classes that Manim ships with. If you're looking for something, then go to the documentation and use the search function. It will bring you to the corresponding section in the reference manual, where hopefully there is some documentation for whatever you're looking at. Now let's do a slightly more advanced example next. I have opened the file firsttutorial.py and have added the import line already. So we've seen circle and square, two rather simple objects already. Let's try and look at something a little bit more exciting maybe. So I'll create a new class. Second example. Again, this should inherit from scene. We write the construct method. And now I want to actually plot a function, meaning that I'll need some sort of axis. And actually the corresponding object in Manim is called axis. So axis, we can specify, if you've set up Visual Studio Code correctly, it actually lets you know the signature of the class, which sort of parameters you can specify. And in this case, I do want to specify an X range and then Y range, so the range of X values and Y values that the axis will contain. So we have X range. Let's maybe go for -3 and from -3 to 3, and Y range also -3 to 3. Not very creative. Let's see. And let's add it to the scene and look what happens. So self.add axis. Okay, I saved the file, and now next I render the thing. So I call Manim, medium quality with the preview. My file is called first tutorial, and the scene is called second example. And what happens is, yay, we generated an object which looks like a set of axes, x-axis and the y-axis. All right. Now to this axis, I want to add some sort of plot, which I can do by saying, well, now I want a variable called curve. This should have my plot of some function. Let's say, and to plot it, I can use the plot method of the axis actually. So I can say my axis dot plot, ax dot plot. And for specifying a function, I could either write a function outside somewhere, define an extra thing, and then pass this here, or I could write an inline function. And in Python, inline functions are specified using the keyword lambda. So I say lambda x should be mapped to, I don't know, something sort of funny. Let's put x plus 2 times x minus 2, and maybe that over 2. It fits the screen, maybe. Let's see. And I can also specify the color. Let's do that. The color should be, let's put red. All right, now I have the axis. I have a variable containing the curve, and again, I need to add it to the scene for it to be visible. So I say I add it to this add statement here, and I find, after rendering it again, what do we see? Excellent. We have the plot here. Great. So now what can we do next? Let's get it even a little bit more fancy. I want to, wait, let's open it again. More fancy. I want to plot the area that we see here under the curve. How could we do that? Well, there is, fortunately, we could look it up in the documentation and search for area, and we will find that our axes also have an area method, or a get area method actually. So I can define a new variable, area, which should be ax.getArea. We want to get the area, so the axis should get the area under the specified curve, which is important, so we need to pass that again. And then we should specify in which range we want to have it. That's the x range in this case. And I want to have the area in the interval from x equals minus 2 to 0. And let's see what happens if we add the area now also to the scene. Save and render. And there it is. So now we have created a cute little scene where we have an axis plotting a function. And for this function, we have even visualized the area under the curve in some specified interval. Cool. So there is one pretty substantial topic that we have not touched yet at all, which is animations actually. And that's what we're going to do now. I do want to say a few words in theory again before we start actually coding. One, what's the general mechanism? We have seen that we can add our mobjects to our canvas, to our scene, by using the add method of the scene class, which adds the objects immediately to the screen. But what other mechanisms are there to, well, play animations, for example? One thing that exists is scene.wait. So we would add in our class a call to self.wait and then maybe specify some amount of seconds. This creates a pause in the video, in the animation where nothing happens. So if you go back and do that in the example that we've seen before in our static image, you would see that you would suddenly produce a video, but nothing would happen in the video. It would just be the image you've created anyways. And now the more interesting thing is probably scene.play, so the play method, which plays animations. Now, what are animations? Animations in Manim are just like mobjects or, well, the scene, a special type of object. For example, there are a few animations that can add mobjects to a scene. Two of those are the create animation and the fade in animation. There are animations that can change mobjects. So from transform one mobject into another mobject, it's a transform animation. There are animations that emphasize certain objects, for example, the indicate or the circumscribe animation. And of course, if there are animations that add mobjects, there are also some that can remove them again. In this case, it's uncreate and fade out. Okay, now I've thrown a bunch of names at you. Let's go back to our example and do some coding. Now we want to animate things here. So we could start, for example, by making the axes create themselves on the screen. So we want to have a nice creation animation for the axis. Let me delete that and let me self.play. We want to play the create animation for the axis. And just look at what happens if we do that. So let's go ahead. I render with the same command as before. So manim -qm -p, so that we have the preview of the file, which is first tutorial.py. Second example. And go. Okay, something happens. Video opens. Let's play it. Nice. So we have a 1 second video now where the axes are created. Okay, we want to see more. And sometimes it's also good to add a little pause at the end of the video so that you can look at things before the video player closes itself. For example, if you use VLC, I think it does that. So what I usually like to do is I add self.wait, like 2 seconds in the end, so that the video stands still for like 2 seconds in the end. We have the creation of the axis. Let's now also add self.play, maybe the area, maybe the curve. So create curve. Look at how that looks like. Fancy. So first the axes are drawn and then the curve. What should we do if we wanted to draw axes and curves at the same time? Well, fortunately, you can pass multiple arguments to the play call that you have right there. So we can just take the thing from the play call and then add it to from the second play call and then add it to the first play call. We will find, we run that again. Something new is rendered, and you see the curve. Let's play that again. The curve and the axis are animated at the same time. Both appear at the same time. Nice. Let's use a second animation for making the area appear. So I play. This time let's fade in the area. All right. Let's go and render that. Okay, so first the axes appear and then the area fades in. Very nice. I would like to make the creation of the axis and the curve a bit slower, because right now this happens very fast, and there is a simple keyword that you can pass to either the play call or the animations themselves, however you choose. You can add the keyword runtime. Run_time equals, let's put 3 seconds. If you put it to the play call, then it will be passed to all of the animations in the play call. You could also specify different runtimes for the animations in one play call. So let's try to render this. Okay, now exactly the axis and the curve are take 3 seconds now to create. So you see it's substantially slower than before. Let's try also what happens if we pass different runtimes to the create arguments. So let's put runtime equals let's say 5 seconds for, no, let's say 2 seconds for the axis and 5 seconds for the curve. 5 seconds for the curve. Now the curve should be really, really, really slow. Yeah, that it is. So that's how you can control the playtime of animations in one of these scene.play calls. Okay, we have the fade in thing, and what else? That's all what I wanted to show for this particular example. Let's do another one where we animate some things. Let's go ahead and create a new class. This time it's a let's call it square to circle, because we want to have a look at what happens if we transform one object into another. So let's do that. Again, it has to inherit from scene. We need the construct method. And we create, just like before, a green screen, a green square. Green square. which is given as which is a square. The color of the square should be green, otherwise the green square wouldn't really be fitting. We have a fill opacity that we can set or not, doesn't really matter. I put 0.5 because I like that. And first step, I want to create this square. Self.play. Maybe we'll use a different animation yet again. This time I want to use the draw border then fill animation for the green square. See, it's slightly different to the create animation that we've used before. Then we look at that. That's already enough work for something to look at. Square to circle. It's the new thing I want to render. Let's go. It's rendering, and here is the animation. So it does exactly what the name of the method is. It first draws the border of the object, just like the create method, but then instead of sort of bringing the fill with it, it fades in the fill afterwards. Okay, so we have that. Now I want to create a second object. Let's make it a blue circle again, because why not? Blue circle equals circle. Color should be blue. And again, fill opacity doesn't really matter. Let's again put 0.5. And now we play a transformation. Transform, we transform the green square into a blue circle. And then we maybe we wait at the end of the scene again a little bit. So self.wait. Let's put 2 seconds. Okay, let's render and see what happens. There it is. And first the square is drawn and then it morphs into a circle. Pretty neat. One thing that we haven't looked at yet from all the animations I've mentioned previously are the indicate animations. So we should see what that does. And then also the destruction animation, so the fade outs that we should also briefly investigate. And while doing that, we will actually encounter one issue that Transform has. Let's see what happens if we try to fade out the blue circle now, because our green square has morphed into the blue circle, right? So self.play, fade out of blue circle. What we would expect is that the scene would be empty now, right? So let's try that. Here's our animation, square into circle. And then you could see the thing light up somehow and then become dark again. But the circle is still here. Why does that happen? That's actually a weird thing that Mane does, unfortunately. The default behavior of the transform animation is that the first argument becomes the second argument, which means that now after this line here, after the transform for the green square has been played, the variable named green square contains the blue circle. So if we want to keep this as is, we would have to fade out actually the green square, which is, well, a bit ridiculous, but let's do it. See what happens. Green square fades in, morphs into the circle, and then the circle properly fades out. You could work around it by using a different transform, the so-called replacement transform. So this is a different transformation that actually replaces the original object with the target object, meaning that after this, the blue circle will remain. So if we try now to fade out the blue circle, just like we did earlier, then we will see first the square morphing into the blue circle, and then the circle fades out properly. So that's the difference between the transform and the replacement transform animations. We might fix this at some point. Okay, one last thing. Let's try and see what the indication animation does. So let's self.play. One of them is actually just called indicate. Indicate the blue circle. Could have also just looked into the documentation, but well, trying things out yourself is much more fun, I suppose. First the square, then it morphed into the circle, and you saw this little flash, this little increase of size of the circle before it faded out. That's exactly what Indicate does. It colors some object yellow and makes it a little bit larger for a while. It zooms in and thus makes it pop out of the screen, which is pretty useful to draw the attention of the viewer to some particular part of the screen. Okay, I'll leave it at that for the moment. We'll continue our exploration of Manim in the next video. Until then, I want to know from you. Did you think this was helpful? Should some of the content you've seen in this video maybe even go into Manim's official documentation? If so, which part? Let me know in the comments below. Don't forget to leave a like if you enjoyed this, and subscribe for more content like this to come. Thanks for watching, and see you again soon.